4 different frontier AI models just took a completely ungameable coding test. They produced perfectly identical, 18 out of 18 perfect scores. To get these results, researchers used a methodology called hidden test injection. They disabled network access and injected the questions only during the scoring phase, making it impossible for the models to cheat using contaminated training data. The proprietary model costs 53 cents per fix, Tauraw 15.5 times higher than the GLM 5.2 model's identical perfect score for 3 cents. Standard leaderboards missed this parity because old metrics are broken. OpenAI audited SWE Bench Pro, found incomplete fixes passed, and retracted their recommendation. When proprietary models provide the same result as open-weight versions for 15 times the cost, the premium for closed systems becomes harder to justify. In well-defined coding tasks, intelligence is now a commodity. The market reacted immediately to this benchmark data. Capital is fleeing overpriced proprietary APIs and rerouting toward highly efficient open-source alternatives. Grok 4.5 launched into this environment, perfectly matching frontier capabilities while undercutting the market leaders by 60%. Tencent then released High 3, a mixture of experts model. This architecture routes tasks to specialized subnetworks instead of firing all at once. So while it holds 295 billion parameters, it only activates 21 billion per query, allowing frontier-level performance to run cheaply on standard hardware. For well-defined coding and logic tasks, choosing a model is no longer about finding the smartest AI. It is a basic procurement decision driven entirely by price. So if the core models are commodities, where is the engineering happening? It's all moving to the harness, the complex agentic wrappers, memory routing, and safety scaffolding built around the AI. Take the new self-harness frameworks. Researchers gave autonomous agents the ability to rewrite their own operating rules, letting them dynamically optimize how they process tasks and use tools. These architectural improvements alone yielded a 33 to 60% jump in output quality. The core model didn't change at all, but the system got drastically better. Compare that to the old approach of simply upgrading the underlying AI. Swapping in a supposedly smarter model barely moves the needle anymore. Competitive advantage no longer comes from training the base model, but from engineering the wrapper. Raw capability without a proper harness is actually dangerous, and the public launch of GPT 5.6 provides a perfect case study. The model achieved something genuinely historic. It autonomously generated a mathematical proof for the cycle double cover conjecture, a graph theory problem left unsolved since the 1970s. But that intellectual triumph came alongside operational chaos. The model launched with 36 different API configurations, creating a complex maze for developers and leading to unpredictable subagents spawning on their own. Because it lacked rigid routing logic, these subagents executed endless loops. Users were hit with massive, unexpected cost escalations as the AI spun out of control. Unconstrained model intelligence without proper agentic scaffolding is no longer a product feature. It is an expensive operational liability. Building these massive autonomous agent loops creates a vast physical footprint that software scaffolding alone simply cannot sustain. We saw over $20 billion in infrastructure deals signed in a single week. Anthropic just committed to a $19 billion 20-year lease to power their future models exclusively through a 401 megawatt nuclear data center facility. Software code is now very easily replicated. The ultimate competitive moat has moved to 20-year physical energy contracts and heavy iron. But as this physical and digital scale explodes, we're hitting a severe calibration crisis. The complex harnesses managing these models are simultaneously too weak to stop threats and too restrictive for basic tasks. On the weak side, we have Jade Puffer, the first fully autonomous AI ransomware. It successfully deployed and self-corrected 600 payloads in 31 seconds, entirely without human intervention. The real-world stakes are tangible. Cambridge researchers recently documented terrorist groups systematically using major AI platforms for attack planning. Contrast that extreme danger with safety filters that are far too strong. Fable's system recently blocked a pure graph theory math problem, blindly flagging it as a biological threat. We have successfully solved the problem of creating cheap intelligence. Now comes the challenge of building a perimeter strong enough to hold it.